So back in Sydney, we'd had some fantastic results from foam fractionation, and we were so confident that we thought it was time to take it to the next level. So we converted our Williamstown warehouse into a bespoke PFAS treatability laboratory. And in here, we've conducted, as I said earlier, over 70 discrete experiments to test every facet, every corner of foam fractionation, and trying to work out how to optimize it and make it work as efficiently as we possibly could. We were aiming for some very low drinking water criteria, and so we had to really optimize the process. And it was down here that we managed that process. There were 4 or 5 scientists working here at any given time, working on all of these different facets of experiments, and we were so happy with the results over time. We started with that little Buettner flask. We built it up to the 10 litre protein skimmer until finally some of the big boys that I'll show you around the corner in a second gave us the idea that we could actually commercialise this technology. So if you come around here, I'll just give you a quick look. Okay, hopefully not too noisy. We'd finished in Sydney with the desktop work, and we were super optimistic about the foam fractionation process and how well it was working. So we came down here to Melbourne to start to construct a number of different test rigs. We worked on about 8 different ones over the period we were down here, because there are a number of parameters that we really needed to test to optimise that fractionation process. But the obvious ones of column width and size had an influence. We wanted to look at the bubbles themselves, how they're introduced, what angle they're introduced, where they're introduced from, to optimise the process. We wanted to look at stratification within the system and understand where that PFAS was accumulating within the system. We wanted to look, really importantly, at the issue of co-contaminants, because PFAS doesn't exist in the environment in isolation, of course. It's out there. There's a number of different contaminants, everything from variations in water chemistry that impact nitrate and sulfate contents. We were looking at different colloidal soils and the impacts of clays in the process. And then probably most importantly, we looked at the impact of various types of hydrocarbons to the fractionation process, and whether the fractionator itself could manage those type of co-contaminants. Again, our confidence grew even further, and we started to ask ourselves, well, we've created this layer of foam, how are we going to extract it to create a hyperconcentrate? So we moved to an even bigger scala system. In these larger units, this particular one's a couple of thousand litres and moves us towards the sort of commercial scale we were looking for. We were able to put a lot of work into the design and construction of a really effective vacuum hood for extracting that PFAS foam at just the right moment, when it was just the right density, just the right weight of water in it, for us to really optimise the process and remove, right down to drinking water guidelines, the PFAS that was existing in there, the criteria compounds. Once we've gotten this engineering design to this stage, we handed it over to our design and engineering team up at our Brisbane office and asked them if they could start to look at how they could containerise and modularise these systems to get them ready for field applications, to get them out into the environment, out into the real world doing their job. And while our designers were busy doing that, the scientists down here at Williamstown turned their attention to the rest of the treatment train. We were looking at the pre-treatment issues and how we prepare the water for the process of fractionation and the subsequent polishing that occurs. And then the polishing itself, we were looking at various different types of polishing mediums, various types of absorbents, particularly ion exchange resins, and how these would work for us. So if we come next door, I'll take you through some of the work we did there. With foam fractionation starting to get very refined, we were super happy with the process. We've been able to achieve brilliant results, much better than actually we'd ever expected with the larger fractionation units. So we were removing well in excess of 99% of the criteria PFAS compounds, which was just such a good result. The PFOS, the PFOA, the PFHXS, a longer chain, 6 carbon chain and longer PFAS compounds were stripping out a solution using the fractionation process. That was brilliant. Overall, of the entire suite of PFAS compounds that were in the processing water that we were dealing with from a number of different sites, we were removing on average about 86% of those. So we still had a small amount of PFAS to deal with. The fractionation had far and away done the heavy lifting, preserving things like the resins, but we wanted to be able to really get that out so that it wasn't just a drinking water criteria for those longer chain PFAS compounds. We wanted to remove everything that we found in our topper testing process. So to do that, we lean on some of these more conventional systems, the GAC and the resin, to deal with it. We went to resin suppliers from all over the world. We got samples in here. We did over 20 discrete experiments to test those against a range of different water chemistries. We tried them against a number of different co-contaminants just to see how they'd be impacted, how they'd be degraded, how their efficiency would be compromised, until we were really happy that we could go out into the field on these sites that we were dealing with and treat that water to the best possible standards. There were 16 stages in total that we developed for OPEC's water treatment plant for PFAS. 2 of those stages are foam fractionation, so you can imagine it's actually quite a complicated process to get right. But through the works we did here at Williamtown and the persistence of our team to look at every single facet of the water treatment process, we're now really happy with what we've got. We've got one of the first commercial, full-scale PFAS water treatment plants in the world, and we're also very confident that it'll work in a range of lithologies, in a range of different water chemistries, in a range of different environments all over the world. So couldn't be happier.